This will be the first of the last two lessons on mass and balance, in which we will learn how to complete a combined load and trim sheet. The load and trim sheet is split into two sections, Part A and Part B, and we will deal with Part A first. The completed load and trim sheet will show the loading and centre of gravity of the medium-range jet transport in CAP 696, which we have been studying. It represents the type of load and trim sheet that airline operators currently use, and you may be required to complete part of one in the EU Mass and Balance examination. The load and trim sheet is split into two parts. The left-hand side of the page, called Part A, is the loading document, which itemises the mass distribution within the aeroplane, such as operating mass, traffic and fuel load. The right-hand side, called Part B, shows how the position of the centre of gravity, represented by mean aerodynamic chord, alters with each change of mass. The zero fuel mass and the takeoff mass are finally plotted in the graphical envelope of Part B, and they must be within the operational limits. Part A is split into three sections. Section 1 is used to establish the limiting takeoff mass, maximum allowable traffic load, and any underload before last-minute change. Section 2 shows the distribution of the traffic loads and includes some abbreviations, which are shown on screen. As a reminder, the abbreviations are in CAP 696, which is available during exams. And Section 3 is a summary of the loading, including a check that limiting values are not exceeded. Starting with Part A, with a given set of data on screen, we will work through an example to eventually establish the relevant centre of gravity positions in Part B. There is no provision to consider the maximum structural taxi mass in the load sheet, but as we learnt previously, it is a limitation. In this case, the taxi fuel allowed for is 260 kilograms, the difference between maximum structural takeoff mass, 62,800 kilograms, and maximum structural taxi mass, 63,060 kilograms. Notice that in this example, because there are no performance limitations for takeoff and landing, the regulated limiting mass is the maximum structural takeoff mass, 62,800 kilograms, and the maximum structural landing mass, 54,900 kilograms. We will progressively enter the required data into the appropriate box to complete Section 1 of Part A, starting with the allowed mass for takeoff, the lowest value of A, B or C. Start by entering the dry operating mass, 34,300 kilograms, and the maximum masses for zero fuel, 51,300 kilograms, and landing, 54,900 kilograms. Enter the fuel data, starting with the takeoff fuel, 14,500 kilograms in both the first two boxes, followed by the trip fuel, 8,500 kilograms in the third box. We can now calculate the three potential takeoff masses, and the lowest of these is the allowed mass for takeoff, A, B or C. The value at A is obtained when the required fuel, 14,500 kilograms, is added to the maximum zero fuel mass, 51,300 kilograms, to give 65,800 kilograms. Enter in B the regulated takeoff mass, 62,800 kilograms, which in our example corresponds to the maximum structural takeoff mass limitation. The value at C is the takeoff mass that would be achieved if the aeroplane were to land at the regulated landing mass, with the mass of the trip fuel added back to it. In this case, add the trip fuel, 8,500 kilograms, to the regulated landing mass, 54,900 kilograms, to give 63,400 kilograms. The maximum mass that can be allowed for takeoff is, of course, the lowest of the three values, B, 62,800 kilograms. Before we can calculate the allowable traffic load, we must first calculate the operating mass. This is achieved by adding the takeoff fuel, 14,500 kilograms, to the dry operating mass, 34,300 kilograms, which gives 48,800 kilograms. Transfer the 48,800 kilograms in the direction of the arrow to the column under B, 62,800 kilograms. To find the maximum allowed traffic load, we must subtract the operating mass, 48,800 kilograms, from the value at B, the limiting takeoff mass, 62,800 kilograms, which equates to 14,000 kilograms. The next step is to calculate the total traffic load, and to do this we will use section 2 of the load sheet, and start by entering the passenger load in the distribution mass box at position O. The passenger total is 130, and using the average mass of 84 kilograms per passenger equates to 10,920 kilograms. The total passenger baggage is calculated by multiplying the total passengers, 130, by the average baggage mass, 14 kilograms, to give 1,820 kilograms, which is entered in the row marked B under the heading Total. The baggage is shown as distributed, 600 kilograms in hold 1 and 1,220 kilograms in hold 4. The cargo load of 630 kilograms is loaded into hold 4 and entered in the load sheet at box C and under distribution mass 4. The totals under distribution masses can now be entered under each box in the row marked T. Hold 1, 600 kilograms, hold 4, 1,850 kilograms, and passenger cabin O, 10,920 kilograms. We can now calculate the total traffic load by going into the start of section 3 and entering the total of baggage and cargo, 2,450 kilograms, and below it the total passenger mass of 10,920 kilograms. By adding the baggage and cargo mass, 2,450 kilograms, to the total passenger mass of 10,920 kilograms, we arrive at a total traffic load of 13,370 kilograms. The total traffic load must also be entered in section 1, in the total traffic load box. The underload can now be established by subtracting the total traffic load, 13,370 kilograms, from the allowed traffic load, 14,000 kilograms, which gives an underload of 630 kilograms to allow for any last-minute changes. We can now complete the final part of the load in section 3, in which the actual zero fuel mass, takeoff mass and landing mass is calculated. To check against the possibility of exceeding the limiting mass of zero fuel, 51,300 kilograms, takeoff 62,800 kilograms, and landing 54,900 kilograms, the limitations are entered in the appropriate boxes. The next step is to enter the dry operating mass, 34,300 kilograms, and add it to the total traffic load, 13,370 kilograms, to give a zero fuel mass of 47,670 kilograms. To the zero fuel mass, 47,670 kilograms, we add the takeoff fuel, 14,500 kilograms, to give a takeoff mass of 62,170 kilograms. The landing mass is calculated by subtracting the trip fuel, 8,500 kilograms, from the takeoff mass, 62,170 kilograms, to give 53,670 kilograms. Check that the maximum values in the 3 boxes for 0, takeoff and landing mass have not been exceeded. We have completed all of the requirements of the load sheet and established the underload, the 0 fuel mass, the takeoff mass and the landing mass, and check that limitations have not been exceeded.